We're back with the humongous book of calculus problems, my favorite book. Find the general solution to the equation. And we're given 4 cosine squared theta minus 2 equals 0. And this is a trigonometric equation. And I know that because there's cosine function. And we need to solve for theta. Just like we solve for x, we want to know what theta is. I'm going to add 2 on both sides, which will give me 4 cosine squared theta equals 2. Now I want to divide by 4 on both sides, which will give me 2 over 4 on the right side. And that is just 1 over 2, if we simplify it. Now I'm going to take square root on both sides. That will give me cosine theta equals plus or minus square root of 1 over 2. Now I want to do some stuff with square root of 1 over 2 because it looks kind of iffy. Square root of 1 over 2 is going to equal to square root of 1 over square root of 2. And that's equal to 1 over square root of 2. Now this still looks iffy, so I'm going to multiply by square root of 2 over square root of 2, which is just 1. So we're not changing the problem, we are just writing it in a different way. Now that will give me square root of 2 over square root of 2 squared. The square root is going to cancel out with the square. So we are going to be left with square root of 2 over just 2. Now that is a number that I want to see because in the unit circle, if you realize that the square roots are always on top, that is a standard way of writing it. So that's what I want. Let's plug it back in. But now I'm going to take inverse of cosine on both sides, which will give me theta equals to cosine inverse of plus and minus square root of 2 over 2. Now because cosine can be positive or negative, we are going to have many different answers. More specifically, we're going to have infinite many answers because we're not given any interval, we're not given any limit. But let's start with quadrant 1. Now we know that pi over 4 gives us square root of 2 over 2. And we also know that 3 pi over 4 is also going to give us that number, but it's going to be negative. Now 5 pi over 4 is also going to give us that number. And it's going to be also negative because x values are negative in the second and third quadrant. Now 7 pi over 4 is going to give us square root of 2 over 2. And there is going to be positive. Now all of these are our answers. But how do we give the general answer? We can represent it by introducing another variable, which is k. Now I will write theta equals pi over 4 plus 2k pi because 2 pi is a 1 revolution. And if we add to pi over 4, we're representing as many revolutions, whatever k is. And then we're going to do the same for all the other angles. K is going to be 0, 1, 2, and it keeps going. That's how we represent infinite many answers. And we're done. That is our answer. Now this problem is interesting. At least it looks interesting for me. They said to calculate the exact solution or solutions to this problem. And it's different than the last one. They don't want infinite many answers. They want exact solution. So let's see. Tangent squared theta equals tangent theta. I want to subtract tangent theta from both sides, which will give me tangent squared theta minus tangent theta equals 0. Now, I can factor out tangent theta, which will give me tangent theta multiplied by tangent theta minus 1. Now, because we are multiplying, we can separate them, which will give us tangent theta equals 0, and the other side will be tangent theta equals 1, because I move minus 1 to the other side. Let's solve the left-hand side. if I take the inverse of tangent on both sides, I will get theta equals tangent inverse of 0. We can think of tangent as sine inverse of 0 over cosine inverse of 0. We gotta think of an angle that makes sine 0, and we don't care about cosine. We know that cosine is not going to be 0 because if it's 0, it's gonna be undefined. And for that one, theta is going to be 0, meaning when angle is 0, sine is 0. On the other side, we will do the exact same thing, but we have 1 there. So we will get theta equals tangent inverse of 1. Or sometimes we say arctangent, they mean the exact same thing. Now we want something that makes tangent 1. That means sine and cosine have to be the same. And the only angle that makes that true is pi over 4, because that's only when sine and cosine are the same. That makes it that our answer is 0 and pi over 4. You might be asking, why aren't we adding 2 pi like last time and we're not doing that infinite thing? Let's draw out inverse of tangent function. Like I said, cosine cannot be 0. So that gives us information that there's an asymptote at pi over 2 and at negative pi over 2. And the function of tangent inverse looks like this. It never touches those red dotted lines. It will never touch them. It will go towards it, but it will never touch. And our answer, pi over 4 and 0, actually lie inside that limit. So it is safe to say that there are our exact answers. So we're done. Now I want to try to solve this problem in a slightly different way. What if we divide by tangent theta on both sides? That means tangent theta is going to be a denominator. So we have to say that tangent theta cannot be equal to 0. The right hand side, tangent theta is going to cancel out, which will give us just 1. And on the left hand side, we will just get tangent theta. Now it looks the same, so we will have tangent inverse of 1, which will give us theta equals pi over 4. Yes, that is the answer that we got last time, so that is correct. But we just lost our other solution, which is 0, and that is wrong. So I don't recommend doing it this way.